Hey guys, Mrs. Traver here. We're going to walk through notes on polynomial functions today. So let me get this pulled up. All right, so here's the game plan on these. We're going to first try to classify them each. So we're going to go through what each of them are called up to degree 5. So let's get those going. First off, degree 0 is kind of a weird one. Those are the ones that look like y equals 5. So those are just plain constants. So degree 0 is a constant. Notice what we're talking about with degree is the exponent on the x. So notice this one doesn't even have an x. There's no x at all. So it's degree 0. And that's just a constant function. I should say a constant polynomial function. If you have degree 1, then it does have an x, and it's x to the first degree. So an example would be like x plus 2. There is an x, and the exponent, the highest exponent you see, is to the first. So this is degree 1. That's a line. So this is a linear function. We spent a lot of time here in algebra 1. The next one is one where we have something like x squared plus 2x plus 1, for example. This one is a quadratic function. We spend a lot of time here in algebra 2. These are the parabolas, so we call this a quadratic function. Moving forward, these ones get a little weird looking. Actually, let me move backwards for a minute. This would be a vertical line. This would be any line. This would be a quadratic, to get a little picture in mind. The next one is to the third. So an example is like y equals x cubed plus x squared plus x plus 1 with any coefficients in front of those guys. But these ones look like this. All right, and they are cubics. The next one is to the fourth power, so you kind of get the idea where we're going here. Something with x to the fourth. And by the way, we don't have to have all the terms in here. It could be like x to the fourth plus 3x and not have an x cubed term or an x squared term or a constant term. As long as the highest degree is to the fourth, then this is a degree 4 polynomial. Degree 4 is called quartic. You can remember that one because it sounds like quarter, isn't it? And there are 4 quarters in a dollar. So quartics look something like this. It looks like it's got like a couple parabolas in there. Our next one is degree 5. This one is a quintic. A quintic, so again, this one has something to the fifth. Maybe it has a fourth term and a squared term and a constant. A quartic function, degree 5, could look something like 1, 2, 3. There we go. Could look something like that. So you can tell they're just getting more complex as they go. In the next sections later, we're going to talk about how we know if they're going up or down and what direction they're going in and whatnot. But this is just like basic examples. These don't even really match each other if you're checking that later. I just want to get you an idea of what these look like, and it's just going to get more curvy as the degree goes on. The next thing I want to say is to notice that after we get past 5, we're going to start running out of words here. So if it were me, I'm probably only going to use the first 6 terms: constant, linear, quadratic, cubic, quartic, quintic. And these are ones you'll have to memorize, unfortunately. If you get past that, some big degree n, let's say, we can just say nth degree. And that is literally, oh my goodness, I can't spell. Once we get past that, though, we're just going to call it the nth degree and not really worry about what the name of it is. We could call it an nth degree polynomial. And this would be like something where whatever n is, maybe it's 21, it'd be the 21st degree polynomial. We could write that out. But knowing the names of them is one thing. The next thing I wanted to mention is what standard form looks like. So standard form for any polynomial, regardless of the degree, is going to be in the exponents are going to be in decreasing order. So let me write that as an example. We would like it to be in descending degree order. So for example, if I had 2x to the 5th plus 3x to the 4th plus x cubed minus 2x squared plus x minus 12, notice my exponents are going 5, 4, 3, 2, 1, 0. There's not even an x there, so it's like an x to the 0. So descending degree order, and now I can tell that this is the very first term is the leading coefficient. So this is the degree 5, and it's called a quintic. So you should be able to take any polynomial, put it into descending order, and tell the degree and the type of it. If you get one that's not in standard form yet, you have to move things around. So say you had one that looked like this, 12x plus 10x squared minus 2x to the 5th plus 12 plus 10x cubed. We need to put it in descending order. So find the highest order you can. It's a 5. Put this term first. Make sure you move the whole term. So the negative goes with the 2. So negative 2x to the 5th. And then my next one is to the 3rd, 10x cubed. Got that guy. Here's a 10x squared. And a 12x and a 12. So now I'm in standard form in descending order. And notice too, I went 5, 3, 2, 1, 0. I didn't have an x to the 4th term, and that's okay. We sometimes don't have all of them. We sometimes only have one. But again, this one is degree 5 and a quintic. So in this section, you should be able to recognize what types of degree there are, name what type it is, and be able to put them in descending order if they're not already. This section's pretty quick. On the next one, we'll work on adding, subtracting, and multiplying these polynomial functions.